regularity that seems to be able to help us explain this. People appear to predict the direction of change fairly accurately, but fail to predict the magnitude of change. So, right, we've seen that with healthy snacks. I know I'll prefer a healthy snack when I'm no longer hungry, but I fail to predict how much more I'll prefer it. I know I'll care less about boop when I'm satiated, but I fail to predict how much less I'll care about it. I know I'll adapt to owning a mug, becoming paraplegic, or winning the lottery, but I fail to predict how much I'll adapt. Fine. So, people violate rational expectations. That phenomenon is referred to as projection bias, and the answer C to the last clicker question sort of points to why we call it that. When people are predicting their future utility, they project their preferences in their current state onto their preferences in the future state. So I know my immediate preferences. I mean, it's impossible to... It's not impossible. We make an assumption that I think is not incredibly unreasonable, that you know your immediate preferences, because there they are tugging on you. Okay? Hard to really make a strong claim that people don't know their current preferences. But what people do is they take those preferences and they sort of project them onto their future self. I know I'm in a changed state, but I project my preferences under my current state onto my future self in a different state. Okay? Total projection bias would be a failure to predict any change in preferences. Partial projection bias is what we see in all these examples, which is you predict the direction of the change but not the magnitude. Now, there's evidence of people actually predicting things going in the wrong direction, but the bulk of the evidence is consistent with partial projection bias. All right. Okay. Simple model. You'll never guess who wrote this model. That's right, Matt Raven. Simple model of projection bias, and it's actually literally called the simple model of projection bias. State dependence is modeled the way we've already talked about. Utility at time t is a function of your consumption at time t and your state at time t. So utility function is written this way with that semicolon meaning your utility for consumption conditional on your state. All right, level of hunger, habituation, your reference point, whatever. Projection bias says that from period t, looking forward to tau in the future, the individual believes her future utility function. I've written down this notation for a prediction of your future state dependent preferences given the state you're in now. Now, what Raven, Lowenstein, and O'Donoghue, and Raven, LOR, 2003, I've cited it so many times I've got it memorized. What they've done is they've specified what they think that predicted utility actually is. Okay, and what they're saying is in their model is that so I'm going to take an alpha mixture of this object here, right, which is my utility for future consumption when I am in my correctly predicted future state, right? So this is, let's say I'm hungry now, but I'm predicting for when I'm not hungry, okay? So that is my actual preferences for food when I'm actually not hungry, okay? The correct future utility function. So that's this thing. And they mix that in an alpha mixture with how they would feel about their future consumption if they were still in the state that they are currently in, ST. Okay? So this is how they would feel about it if their current state persisted. In other words, if they were to project their current state onto their future selves. Alpha, which is a number between 0 and 1, is how much they project their current state onto their future self. Right? So if alpha is 0, then we're saying, no, I'm not projecting any of my present preferences onto my future preferences. Right? If alpha is 0, 1 minus alpha is 1, which means that all of the weight is on your true, correctly predicted future preferences. And alpha of 1 means that we cross out the truth, and we think there's going to be absolutely no difference between how I feel when I'm not hungry and how I feel when I'm hungry. There. That's the model. So it's an alpha predicted utility, it's an alpha weighted sum of current and future utility. That's basically what that is. You can see that this alpha parameter is doing more or less exactly the same thing that beta hat does, right? It's a prediction of changing your future preferences. Okay? All right. Now, again, it's really important for you to grasp that, let's see. So in the beta delta, the utility function with beta hat in it, that's what you believe your future self will make decisions based on. In this case, the u-whittle with the alpha built into it, that is how you believe you will feel in the future, but you're going to build that into your current utility, right? So your utility function, let's say we have 2 periods, the utility that you're actually going to use to make decisions with, your decision-making utility function for, let's say, consumption in 2 periods, given state, is going to be equal to your true utility of consumption in period 1 plus some discount, let's just say beta for the sake of argument, times your predicted utility of consumption in the second state, right? So you're going to take this prediction of how you'll feel in the future and use it to make decisions in the present. It's not just a prediction of how your future self, what choices they will make. It's actually part of how you evaluate the pros and cons of your current choices. Okay? So basically, you're getting the little u's wrong. You're getting your future little u's wrong. You know your current little u. Your current instantaneous utility function is readily available to you. You just consult your preferences and desires now. This is the utility you think you will get in the future from the choices that you make now. Right? So that is part of your actual perceived immediate utility, your now utility function, your present utility function. Okay? So the person makes their current choices based on their predicted future preferences, based in fact on a discounted sum of what my preferences actually are now, what I predict they'll be next period, what I predict they'll be the period after that, what I predict they'll be the period after that. All right, an example. Using hunger, just because if nothing else, it's socially appropriate. All right, so let's just plug some very simple stuff into this projection bias model. Suppose a person has preferences over burgers B and money Y. So you can think of Wimpy from Popeye, right, who would gladly pay you Tuesday for a hamburger today. What we're actually going to want to know is how much would Wimpy pay you now for a hamburger on Tuesday. Okay, am I just too old? You don't know Wimpy? You do know Wimpy? You do know Wimpy. Okay, so formally, the consumption, right, is this vector, a certain number of burgers, a certain amount of money. Preferences depend upon state of hunger, h and whatever, h of t, so it changes from period to period, 0 or 1, where h of 1 is hungry, ht equals 1 is hungry, ht equals 0 is not hungry. And so the state-dependent instantaneous utility function, the true state-dependent utility function, that's supposed to be a semicolon, is u of burgers and money conditional on your hunger state. Okay? And this is what it's going to be. I'm just going to specify. It's going to be bt plus yt, so number of burgers plus number of dollars, if you're not hungry. And it's going to be, so I'm missing semicolons everywhere, it's going to be 5bt plus yt if you are hungry. So in other words, when you're not hungry, a burger is worth $1, and when you are hungry, it's worth $5. Not, I think, unreasonable. Okay, so given that simple model, here's what I want you to do, and this may take you a minute or two, and I want you to work in groups. Suppose that alpha equals 0.75, so a considerable amount of projection bias. Assume, again, linear money utility and normalize current wealth to 0, which means that YT is either going to be 0 if you don't buy a burger, or it's going to be minus the buying price or minus your willingness to pay if you do buy a burger. And likewise, we'll normalize your current number of burgers to 0, so burgers is either going to be 0 if you don't buy one, or 1 if you do buy one. And you're deciding now, when you're not hungry, okay, at t equals sorry, that's actually supposed to be h. I apologize for the typos. So when you're not hungry, h equals to 0, you're making a decision, a binding decision. How much would you pay me right now when you're not hungry for a burger that I will deliver when you are hungry? So this is like the Reed and Van Loen study. Okay. So this is Wimpy being asked on Tuesday when he's not hungry how much he would pay for a hamburger. Sorry, today for Tuesday when he is hungry. So the first thing, this is the same as when we were doing reference-dependent preferences. It's the same every time you ever do decision-making modeling in microeconomics. First, you figure out the utility function upon which they're going to make decisions, which is their perceived utility function. You wiggle. You have on the preceding page what that is. It's an alpha-weighted sum of their current and future utility functions. So write it down there. And then use that, plug in the alpha that you've got, which is 0.75, and compute the perceived value at t equals 1, at t equals 0, good Lord, for a burger at t equals 1. Okay? Go. Do that thing. Change your frequency. You guys can work together on this if you want. I know sometimes math is just easier to do by yourself. Is this making sense? Not at all? Not even a little bit? Okay, let's do this. Click a button. If it doesn't make any sense at all, just make it E. That's fine. Click a button, and then let's look at what we got. Everybody go and change your frequency. Click your button. Did you change your frequency, Alex? Okay, so what did you get? No, I'm not going to look at what you said right now. I just want you to get credit for that. So let's just do the first step of this, okay? So your perceived utility function, you wiggle, is going to look like this. It's going to be alpha times the utility that you place on a burger in the future and some money in the future when in the state of hunger that you actually have now, which is not hungry, plus 1 minus alpha times the utility that you will have for burgers and money in the future, conditional on the state you will be in the future, which is to say hungry, okay? Which is what? It's 0.75 times the utility that you would get if you stayed in your current state, which is b tau plus y tau, right? That's just a burger being worth $1, plus 0.25 weight on how you would feel about a burger if you were hungry, which is 5 times b tau plus y tau, okay? So that gets us that far. Now what we're going to do is what we always do, which is we're going to say, well, what would b tau and y tau be if you bought a burger? What would b tau and y tau be if you didn't buy a burger? Set those things equal to one another and solve for willingness to pay, right? Does that make sense? That procedure makes sense to folks? That's just utility maximization, which we always do and hopefully always will. If you ever come back to college and discover that economists are teaching models that do not involve utility maximization, run for the hills. That's not economics. Can't believe how conservative I've become. So what is this? Well, if you don't buy a burger, what's your utility going to be? Because we've normalized your wealth to 0 and your burgers to 0. So what utility are you going to get if you don't buy a burger? 0. Okay, so we want to know what combination of burgers and money would give you utility of 0, right? So what should I plug in for burgers? Right, this is I buy a burger, so b tau is 1, right? In a scenario where I buy a burger. So my utility function is I'm going to plug a 1 in there, and I'm going to plug minus willingness to pay, right? Minus your willingness to pay. If you buy a burger, you're going to wind up with 1 burger and negative willingness to pay money, okay? So you're going to perceive your utility for that as you put 75% weight on having 1 burger and negative willingness to pay dollars, and you're going to place 25% weight on having, one udel from the burger versus having 5 udels from the burger and giving up your willingness to pay. Okay? Notice that you don't have state-dependent preferences over money, just over burgers. And if you simplify that, what you get, so the condition for willingness to pay, right, is the indifference condition, so that needs to be equal to 0, which is another way of saying that if you do the simplification, you get 0.75 plus 1.25 minus willingness to pay is equal to 0. I skipped a lot of steps, which means willingness to pay is equal to 2. Okay? That's how you do this kind of problem. Figure out the utility function, plug in the 2 choices. One is no burger, no money lost. The other is 1 burger, some money. Set them equal to each other. Solve. Okay? Important question. Will the person regret their resulting behavior? And so suppose I come along and I say, well, I'm very sorry to tell you that the price of a burger is actually $3. And you say, well, my willingness to pay is only 2 because I'm projecting my current lack of interest in a burger onto my future self. You don't buy a burger. You get to the, let's say this is, I'm selling you burgers for when you get to the top half dome. You're very, very hungry. And I say, sorry, you didn't pay for a burger, so you don't get one. Don't let this happen to you. Take a burger with you. Okay. That is simply to say that we can think of it as for sure a mistake. Okay. Okay. Okay, I'm going to skip a bunch of math because I need to get to the punchline on this. So I've come up with a couple of terms: shiny object bias and the Packard effect. If you find yourself talking to a real behavioral economist, you'll need to explain what those terms mean because I made them up. They both have to do with durable goods. So this could be anything from an automobile to an iPhone, anything that you don't consume right away. the paper that you've got assigned, Lowenstein, Donohue, and Rabin, where they write down a simple model, they explore projection bias. What are the implications of their model when an individual has fluctuating, when demand for a durable good fluctuates over time, right? So on high demand days when you're thinking, gosh, I really have your state of desire for an iPhone, for example, just varies. Like, I don't know with what, whether or not you're surrounded by other people with iPhones. So on a high demand day, you project that you will always have high demand. I'm always going to really want this iPhone. And then you buy on a high demand day, right? Of course you are. You're going to buy when your demand is highest, and your demand is going to be highest when you're in this high state of like, oh, I'm surrounded by people with iPhones, I just got to have one. And because you project that will always be your utility state, you say, all right, I'm rushing out and getting an iPhone. Today's the day, right? And then you spend most of your life, I don't know, alone at home, doing the same thing on your iPhone that you did yesterday on your BlackBerry, and you'll spend a lot of low demand days regretting your choice. Okay? Now, if I'd used this Samsung as an example, it would of course be totally different. All right, not true. Here's another way that projection bias could affect the market for durable goods. This comes back to the whole thing I've been harping on about misprediction of adaptation. Suppose that consumers have reference-dependent preferences with loss aversion, right? So when I've got the good, I really don't want to sell it, but before I get the good, I predict that when I get the good, I get some gain utility, I get some consumption utility plus a gain bump. If I have to give up the good, I lose the utility, the consumption utility, but I also get this loss bump. It's the gain bump that I'm interested in initially, okay? The reference point is lagged consumption, right? So I don't have an iPhone, so my reference point is not having an iPhone. I get an iPhone, I get a gain bump in utility, but then it adapts over time, and before long I'm used to having an iPhone. It's just as annoying as any other phone you've ever owned. And the idea here is that consumers project that their reference point won't adapt, or perhaps they won't adapt fully, okay? So when deciding whether to buy or sell, they inflate their willingness to pay when buying because they think that this gain utility is going to persist. They think that having an iPhone is always going to feel like this lovely gain relative to their reference point. So they inflate their willingness to pay when buying. They inflate their willingness to accept when selling because they think, oh, when I sell it, I'm going to get this loss, this feeling of loss, and I fail to predict how I will adapt, and so I'm just going to cling to that object because I don't want to experience that going below my reference point for the rest of my life. Okay? We could call this projection biased reference dependence. Now, I actually don't know of any research on this specific thing. I think it'd be a little bit hard to pin down. There is some evidence here, which I'm not going to focus on, of people mispredicting the endowment effect, which is similar to what I'm talking about. That if you ask people to predict how much they would be willing to sell their mug for right before you give them the mug, you say, hypothetically, imagine I've given you this mug, how much would you be willing to sell it for? They completely fail to predict the endowment effect. So let's say that perhaps we can extrapolate to that to also that they would mispredict the fading away of the endowment effect, getting used to it, okay? I'm not going to go through this math, but I would encourage you to go through it yourself because it's quite straightforward. Actually, no, it isn't. What I'm going to do is I'm going to give you the math and post it on DSpace. But here's what I want you to take a look at. We've got another minute, so please don't get ready to go yet. Here's what this might look like in an actual marketplace, okay? So here's buyers of durable goods having projection bias reference-dependent preferences, basically thinking that getting a new durable good that puts them above their status quo reference point is going to feel yummy forever, okay? What that's going to do is it's going to take the true utility that they will actually get, their rational utility, their rational demand curve, and it's going to bump it up. Right? And this is the thing that they will actually use for making their consumption decisions. I'm calling it DPROJ, the demand curve driven by their projection bias. It's higher. They have a higher willingness to pay for shiny objects because they think that those objects will put them above their reference point persistently, failing to recognize the way in which their reference point will adapt, and so as a result, demanding too much. What would we get? You can do standard welfare analysis here. The quantity will be too high, right? Overproduction. There will be the classic chunk of deadweight loss from overproduction. We're producing shiny objects that are not worth, in the long run, as much as people think that they are, and not worth as much as they cost to make. Okay? The price is too high, which means that money is being transferred from consumers to firms. That's this chunk in here, right? So, by the way, firms have a huge motivation to convince you that this is true. Question, why is this policy relevant? Could this exacerbate environmental problems? What might this say about the efficacy of trying to find happiness through wealth or through consumption? There's a lot of evidence that says, actually, you're better off spending your money on experiences than on objects. What I would encourage you to do is I'll post the math of applying the simple model, and I would encourage you to go through what happens when it's a seller rather than a buyer and puzzle through these welfare effects. I think you should be able to do that, and I think it'll be helpful.